Good afternoon, YouTube. Hello again, I'm Greg from GregsTutoringNYC at gmail.com. Please email me anytime you have any questions about the SHSAT. They could be technical questions or just regular questions. Please like the video, please subscribe, please pass this on to your other friends. SHSAT's a hard test, and you guys need all the help you can get. I don't mean that in a negative way, but nobody's ever gotten the whole test correct as far as I know. So it is a challenging test, and it's what we're here for. So let me just jump right into this. Again, in the lightning rounds, just kind of taking smaller concepts and smaller examples and sort of bite-sized things and working through them. So I do longer YouTubes with more detailed questions on those. I eventually may morph this into those, maybe doing one at a time, like one really good meaty question, lasting 10 or 15 minutes. So yesterday, I was scrambling, and I probably should not have done the lightning round at all. The last problem we had was the square root of 5 factorial. And I mentioned how to solve it, and then had the end number, and I didn't actually solve it, and I ended the YouTube. In fact, when I played it back to see what happened, it's actually cut off. So, so again, factorial, we'll just jump into here at this point. Okay, factorial means, so if I have something like 6 factorial, it's the same as 6 times 5 times 4 times 3 times 2 times 1. Again, you guys should know these concepts already, so this is just really a refresher. You may have had this like last September or something, and now you're like, wait a second, what the heck was this thing? So, and you don't know what the subtopics on the SHSAT is going to be, or any other standardized test you're taking. So when we have the square root of 5 factorial, what we're looking at is 5 times 4 times 3 times 2 times 1. So if we multiply these out, we get 5 times 4 is 20, times 3 is 60, so we get the square root of 120. Now, on some tests or some forms, this is acceptable. Okay, the question is, can we simplify this in any way? When if you played the end of yesterday's, which I guess is lightning round number 6, I mentioned that 4 was an issue. So when we have a radical, this is called radical 120. The question is, can we split this into 2 pieces where we have x times y? We can, because we know the 4 can be separated out. So we have the square root of 4 times, and then the rest. 5 times 3 times 2 times 1. So we know this is 4, and this is 30, because we know we had 120 already. So when we have something like that, the square root of 4 times 30, we're allowed to split this into 2 pieces. So it becomes the square root of 4 times the square root of 30. And the square root of 4 is 2, so we get 2 to the square root of 30. 30 can't be simplified any further. If we go back to what I said yesterday, this is about 10 point something, and this is between 5 and 6. So 6 is a little too high, 5 is 25 is a little too low. So it's maybe 5.5, and if we multiply that by 2, we get about 10, the high 10s. So it's still the same number, and it depends what they're looking for. Sometimes this is the form, and that's acceptable. Sometimes they're looking for this form, especially if it says simplify it, you have to bring it down to that. And if it says to actually solve it, you need to use a technique to actually get there. So for the purpose of, say, grade 7, grade 8, the ISEE, the SSAT, even the PSAT, they're not really necessarily going to ask you to split this up. They may ask you to give it maybe to 1 digit on the tenths. That most of you should be able to figure out even just by brute force. All right? So you might end up with, say, 10.5 is the actual answer. But most likely they're really shooting for this. This is most likely the answer they're shooting for, including in the SHSAT. So they might give some choices. In fact, the SHSAT might give this choice, the square root of the 120 and the 2 square root of 30. Remember, we're shooting for the best answer. This tends to pop up more in the ELA section, where what's the best thing? The best thing, you know, which definition matches it better? What's the context? This could be two explanations of, say, the main idea of a passage, but one is better than the other, or one is a subset of the other. So we always rule for the super answer and stuff like that. Well, that's the case here too. And in fact, if it gives you both answers, first of all, if it says to simplify, you need to be giving this answer. Okay. If it gives both answers and it doesn't say to simplify, you still want to give this as the answer, because it's the most simple form, and normally that's what they're shooting for. You could argue the question is ambiguous then if it has two answers, or at least the answers are ambiguous. But normally they're not shooting for that. They're shooting for the best answer. And we're often told on all our tests, simplify. So unless it says leave it in unsimplified form, then it would be 120. So read the instructions and you make pragmatic, practical sense out of your answers. So that's a little tidbit on a lightning round here too as well. Make your answer make sense. All right. And again, if you guys, wait, did I just lose? Wait a second, I think I just lost my phone. Wait a second, I think the cable disconnected. Let me put a letter X here and see if it comes through. Wait 1 second. No, it seems to be coming through. Anybody watching this? I see the view count is up to 3. So there is people looking on here without saying anything. All right, so that double checks that the YouTube stream is working as well. All right, so if you have any questions about this, go back to your Google stuff, go to Khan's Academy, look through your textbook and figure out what a radical is, what square root's about, and things like that, and see the part you may have missed, as well as factorial. All right? All right, so let's try another topic. Let me see, I have a whole bunch of examples scattered about. How about this one for simplicity purposes? I'm running out of scrap paper. So if I have 99 times 99 squared, what is that equal to? And I'll give choices. 198, 297, 9900, and D is 970299. This is one you try to, good one to pause the video on and try to get it going. All right. So the first question is, what does this really even mean? What does this mean? This is multiplication. Just like if we had A times B like that, A times B squared. We have 99 squared times 99. There's a couple of ways to do it. One way to look at this is this 99 to the 1 times 99 squared. In this case, the parenthesis is not doing it as any good. So it's as if we have 99 to the 1 times 99 squared. So we ended up getting 99 cubed. Because when we multiply things, we add exponents. So there's a couple of things going on here you have to realize. You have to realize this actually maps into 99 cubed. And there's a couple of ways you can do that just by figuring that out. If you do it the exponent way, you have to understand that too. So again, if you're not don't know these concepts, you got to go and refresh them. Because again, the SHSAT examples are going to be harder than all of these. All right? So now that we know it's 99 cubed, which one of these is that answer? So if you don't know it's 99 cubed, you might do silly things like do 99 plus 99. Think this means 99 twice, which gives you 198 just by addition. That's no good. Okay, and it also doesn't mean to add it 3 times, which is that. That's no good. So the question is, now that we have these two numbers, how can we use our number sense to make pragmatic, practical, and efficient sense of 99 cubed? Do we actually go down and do 99 times 99 and figure that out, and then multiply whatever that is, blah, and do blah? times 99 again? Do we do all that? Some cases it is what we do. Okay, in this case it's not. Because if we have 99 squared, using our pragmatic sense, it's almost about equal to 100 squared. Right? The answer is going to be very close to that. And again, do we do 100 times 100 like that? No, we write 100 and we add 2 more zeros for 100 times 100 and then 2 more zeros. So the answer turns out to be about 1,000,000, which is what D is. All right? So we're using our number sense and our just little things we know about how to do basic arithmetic and basic mathematical concepts. And we can double check this a second way, because we're not going to do the 99 times 99. I mean, if you want to, go ahead and do this and then multiply it by 99 again. But there's another mathematical concept that leaps out of here. When you do this addition, this multiplication, whatever result you end with has to end in a 1. If you don't believe me, go do the calculation. In fact, it's true of anything. Just to give another example, if I have 22, it doesn't have to be the same digit. If I have 23 times 45, the answer here has to end in a 5, because that's the first thing we do. 5 times 10 is 15, and then we start going this direction. But the second line, we skip over 1, so it has to be a 15. So just to do another example, 19 times 23, whatever that answer is, it has to end in a 7. All right? So if we come back here, if 99 times 99 has to end in a 1, and we multiply it by 99 again, if we apply the rule a second time, whatever the answer to of 99 times 99 times 99, because 1 times 9 is 9, the answer has to end in a 9. And if all the choices I gave, this didn't end in a 9, that didn't end in a 9, that did not end in a 9, and that did not end in a 9. So we have 2 ways by using estimation, because this was closer to 99. So I set up the example. First of all, many of my examples use the number 99, just because I think it's an awesome number. All right. But in any event, a lot of examples on standardized tests are made to be fitting this way. They're not always just trying to practice and forcing you to do this long multiplication stuff. This is a test on concepts and being creative. Okay? It's not the SHSAT and a lot of other standardized tests, except for things like the state test and the SAT even. They're testing you on your knowledge, not on your use of the knowledge as much. The SHSAT is testing you on your creativity, going out of the box, and your mathematical prowess, right? So you want to be able to do stuff. Plus, you want to be able to solve this problem in a minute and a half, because that's about what you want to do on all these questions. You have 57 questions in the math and 57 in the ELA that you have to answer within 3 hours. So that's about your average time you should be spending on any problem. And if you're going to be doing 99 times 99, maybe getting it wrong and multiplying that by 99, and probably getting that wrong too, because these are error-prone stuff. This is where we make some of our mistakes. In some of the simpler parts, we make silly errors. We do off by 1. We might think 9 times 9 is not 81. We might think it's 72 or something like that. You know, I work with students who are very clever, but they actually still don't know the full multiplication table yet, especially squares. You should know all your squares up to 20, and they come up all the time on these standard tests. All right, so that's a way to double check. So just to make a last comment about this problem, if the example wasn't 99, let's say it was 33, we can still use this last technique to double check, because 33 times 33 is going to end in a 9, and whatever that number is ending in a 9 times 33 again is going to end in a 7. So any answer that ends in a 7 would be the choice, and the others wouldn't. Now, there are some tests where all the answers would have ended in a 9, and then this strategy throws out the window. But at least it confirms that you're on the right track, that you're understanding the mathematical concept, you're understanding the word problem, you're understanding the question, or whatever the case may be, to get to the point of even doing that, okay? So that's awesome. And by the way, sometimes the SHSAT will throw a simple question like this on it, just to kind of throw you off. Because kind of a yin-yang that happens. The problem with a hard problem is it's hard. The problem with an easy problem is it's easy. There's also a second problem with an easy problem. The second problem with an easy problem is actually it might be a hard problem. You don't realize it. And there's just something you forgot or something you're overlooking in the question. I was tutoring a kid yesterday who's very smart. And there was something almost as simple as this. And one little tiny aspect of it, one little mathematical identity or whatever it was, just it's easy to forget. Which is, by the way, I tell you guys to write down as much as possible on your scrap paper. Do the least amount of possible in your head, and have a way to double check it. So even if you use the 100 estimation technique here, you have the last digit technique that I just showed you as well. All right, so we kind of beat that to death, but in a lot of problems, this is perfect. I tutored kids in the grade 8 New York State test, the math test, and also the grade 9 integrated algebra test, which some grade 8 kids take and even some grade 7 kids take. And this comes up often using this last digit kind of thing. In fact, I can even recall I also tutored a kid in the grade 4 math state test, and this came up. All right, so use the math you know. It's the same as the example we did in a couple of our lightning rounds, or maybe it was a longer one, like how do you know if a number is divisible by 3? If its digits add up to 3, or if you repeat doing that, whatever you add up the digits, and you keep adding them up until you get something small enough that you can see and you know is divisible by 3. And there's other rules like that too. These are some people might call them tricks. I call them techniques. It means you're understanding the math to be able to understand why that tip might work. All right. So let's try another example. I think we're going past 15 minutes right now. So let me see. Let me see. By the way, some of you guys don't know what cube root is. Just to throw that out there. Normally when I have something like this, and we say that's 4, there's an implicit 2 here, because this radical form is so common. But we can also use something like 64 and put 3 there. So this means the square root of 16. What number times what number gives us 16? So this is asking what number times what number times what number equals 64. And you have to backtrack that. The answer would be 4. But 4 times 4 is 16. And 16 times 4 equals 64. So if you see a notation like this, that's what that's talking about. As well, there's another form of square root, which I covered a number of times here, which is, this would be 16 to the 1/2. This and this are equal. This means the square root of 16, so that's equal to 4 as well. And on that same notion, if I have the cube root of 64, that's the same as 64 to the 1/3. All right, this means the cube root of 64. That means the cube root of 64. So if this is 4, that's also 4. All right. Let me see if I have another simple example we can do. Yeah, on that note, let's do this one. The square root of x squared. So let me give some choices. X squared. B is x divided by 2. C is 2x. And D is, it's undefined. So some of you, this is kind of problem some of you can do in your head. You can do this in your head because this is conceptual. It's not actually asking you to do a calculation. It's the square root of the thing inside of it. The square root of x squared. So it's not x squared. If it was x squared, that means the square root operation is vacuous. It has no meaning. So just even if you don't know exactly what square root is, it can't be that. Because there's some operation going on here. Square rooting is an operation, just like plus, minus, absolute value. These are all specific operations with mathematical meaning to them. Okay, the square root of x squared is x over 2. That even if you don't know what it means, that's pushing it. So it's not that either. All right? The square root of x squared is 2x. No, that has nothing to do with it either. And the truth of the matter is it's not undefined either. This one I kind of wanted you to make you think through. The answer turns out to be it's x. The square root of x squared. If you go back what the definition is, it's the reversing of the squaring. So if you're squaring something and you reverse it, then you're going to get its original thing. In other words, if we have the square root of 4 squared, that means it's the square root of 16. The square root of 16 is 4, which is the original number we started out with. So it has to be the x. And mathematically, if you tie it back what we just covered over here, that square root means a half. If we have the square root of x squared, this means x squared is being the power of the half. And when we have exponents set up like this, we multiply them. So we get x to the 2 times 1/2, and this cancels out. So we get that's equal to x to the 1, and that's equal to x. And they lived happily ever after. All right, I'm past 15 minutes. We covered a good jumble of topics actually today. Pleased with the scope, especially compared to the video yesterday where I was rushing through it. All right, everybody have a good day, and live long and prosper, people. All right?